Okay.
Okay. All right. So, first of all, I mean, thanks a lot for joining this call. I know it's taking up your weekend, but this is the best time that I could accommodate. Okay. What we will do is I will try to make these sessions as effective as possible. Okay. Uh, we'll spend very little time, right? Let's not uh, have the session for an hour, because an hour is like just too much. You lose your attention, and it isn't that effective, right? So for this next 30-40 minutes, I would request each one of you to pay very close attention to whatever we are discussing. Just make sure that you absorb everything, and if there are any questions, please do not hesitate. Okay, because I'll not be going through this over and over again, these sessions, right? You can always ask me questions, but I cannot go through this again. So please understand that and make the best use of this time. For the next 30-40 minutes, if possible, keep away your mobile phones, don't get distracted. Just listen to what I have to say, and then the next sessions, right, where we will start with one of these BI tools, that will be even more interactive, right? You'll have that sort of connection from this session to the next sections, right? So that's what I wanted to say. And today today what I want to do is I will discuss again about the data warehouse. I know I might have discussed it earlier with you people, some of you, but I just want to lay that foundation once again, in case, just to refresh your memory on, what is data warehousing and how it will help. Because what I have realized is, after these many years, that uh, if you are very comfortable with the basics of the data warehouse, you can pick up any tool, any BI tool for that matter, right? It becomes very easier, right? So the first session that we are starting off with, I want to dedicate completely just to the basics, right? So please pay a lot of attention and listen to anything that everything that I'm saying, and do ask me any questions, right? So uh, today, what we'll do is we'll just see. I mean, this will be a very interactive session, right? I mean, you can always ask me questions, and we'll just have a casual discussion on why this data warehousing started, why do we need it, what's the use of it, how is it different from typical database, database based application, right? So we'll see what is the differences between those applications, right? Right. So moving over to the first slide, the need for metrics, right? Just look at these pictures and look at the text that I have typed in, right? So imagine you are the CEO of a manufacturing unit. Let's say, are you are responsible for that complete floor, right? And these pictures I've just kept there to showcase that there are a lot of activities going on in that unit, right? It could be it could be just people working, or it could be machines. You can even imagine people sitting at their computers, right? Very similar. But all this, as a supervisor, or someone who's accountable for for such a large operation, you will be responsible for making sure if whatever the operations that you're running, if it's making profit or if it's making loss, or is it successful towards the objective, right? It could be your objective or the company's objective, right? How do you measure all that? How do you see that, okay, I'm running this show, this manufacturing plant is running, is it making any profit, right? The way you do that is collecting data, right? Collecting data and measuring. You need to measure. Until you do a measurement, you cannot quantify if your company is making a profit or if it's going under loss, right? So the whole need for data warehousing is the need for metrics. People need metrics to understand how their company is doing. Any questions so far? Okay, I'll take that as a no, right? So just to summarize this slide, you know what I want to say is, what is the need, right? What is the need for metrics? It's someone who's at a very high level, who does not want to get into the details of how the operations are running, but want to understand how profitable is my operations, how successful is my operations towards the company objective, right? That is the need, which is why they need metrics to understand, okay, am I meeting the daily needs, daily goals of the company? So data warehouse is the direct answer to this requirement. The requirement being collecting the metrics and reporting on them, right? And data warehouse isn't, something new. It has been there for ages. It's just that the approach to the data warehouse has changed over time, right? So what is a data warehouse? So warehouse is a very very specific set of tools and technologies that enable reporting on these metrics that we just saw in the previous slide, right? So what do we do in this data warehouse, right? Data warehouse, as the name suggests, data and a warehouse. So you're creating a warehouse, not a physical warehouse, but a virtual warehouse, and you're storing all the data in it. Now that data could be coming from various sources, right? So what is the need? Well, I mean, why do we call it a data warehouse, and what are the special properties of a data warehouse? So these are the attributes of a data warehouse. Single source of information, right? Let me just go back to the first slide for a second. You see here, imagine that these three are different plants, right? Or these three could be, three different departments in different geographic locations, right? As a CEO, or as a director running these operations, you would want the data for all of these to be available from the same place, right? So you can consume it at the same time. You can compare this data at the same time. That's the whole reason of the that's one of the factors for having a data warehouse. Single source of information, right? Then ready for consumption with cleansed and transformed data. This is something that everybody is familiar with. The data that's there in your transactional systems are never directly consumable by the business users. Why? Because the data in the operational systems are usually very cryptic. Like, for example, you do not store the date. Instead, you store an integer that represents the index of the date, right? You do not store the let's say month name. You probably just store the first three alphabets of the month name, and so on. So these values may not be directly understandable or meaningful to the user, which is why you need to convert them. You need to cleanse and transform them. So this is another attribute of a data warehouse. First is, you source all the data, you keep it in one single place. Second, you do some cleansing and transformations of the data so that it's easily consumable by the business user, right? Everybody there?
Yes, Sandeep.
Okay. Sai, Siraj? I heard someone, I wasn't sure if it's Sai or Siraj. Okay, in case you're not able to hear me, please do type in the chat window, right? Okay, so moving on, the next attribute, right? The next attribute is optimized for data retrieval, right? This is very true, because when you have a transactional system, like let's say a point of sale, that application is purely built for capturing data, for recording the data. Now that system is not always suitable for outputting the same information out, right, in huge numbers, right? It takes a different set of arrangement of the tables to make sure that your select query is much more faster, right? Which is why in the data warehouse there is a lot of emphasis for data retrieval. You are not much concerned about how quickly you can store the data, your most concern is about how quickly can I retrieve the data from the data warehouse, right? So this is very important. This is absolutely important because this one sentence will drive your data model design, right? When you're building your data model for a data warehouse, this particular attribute of a data warehouse should be one of the top things in your mind for your consideration. Okay, so please do remember this. And let's say you are attending an interview. Somebody could always ask you like, I already have my database in which we have the data against the transactional systems. Why should I create a data warehouse? Why don't I directly query the transactional system? What's the problem, right? In most cases they expect this answer. They absolutely expect this answer from you, that you have to say that data warehouse is something that is in where the data model is optimized for data retrieval, in comparison with the transactional system where it is optimized for data consumption. It's an input, right? It is capturing the data. It's there are updates and deletes, but here it's all about data retrieval. How quickly can the data warehouse answer the business questions, right? And another important attribute being historical data analysis. This again is very important. This is one of the major differences between a transactional system and a data warehouse. By the way, I'm mentioning transactional system a couple of times now. Does anybody have any doubts on what a transactional system is versus a data warehouse? Meaning, do you understand what a transactional system is? If there's anyone who does not understand what it is, just let me know right away. Okay. So I assume everybody knows what a transactional system is, right? Right. So in a transactional system, the the amount of historical data that is stored is always going to be very less, right? The reason is transactional system is built for one purpose, which is to capture the data, to process it, and to store the data in the database. And it has to be done at lightning speed. It has to be very quick. So almost all the transactional systems uh, will come up with a guideline saying, okay, we will not store data for more than 3 or 4 months in the database. Why? Because as you add more and more data into your transactional systems, the system performance goes slow. The addition of data also becomes slow, right? Overall performance becomes very slow, which is why they continuously move the data. Either they archive the data or purge the data if not necessary. This is in very stark contrast to what we do in a data warehouse. In a data warehouse, we store the historical data as well. Why? Because when you're when a business is asking questions, they would always want to look at historical trend of how the data has been, right? What is the state of the data? How are my metrics of this quarter compared to last quarter? Right. So which is why one very important attribute of a data warehouse, which a transactional system usually does not have, is the historical data, the storage of historical data. Right. So just to recap this slide, these are some of the, I mean, there could be a huge list, but these are the most important attributes of a data warehouse. One is single source of information. You might have different departments, as this diagram illustrates, right? You might have different departments, and they all may be separating they all may be operating separately, but for a data warehouse, all the information needs to be consolidated and kept in one single place, right? Which is why you call it single source of information. That's one. Then next is ready for consumption with cluster and transform data, right? As you can see, the business users are not interacting directly with the sources but with the data warehouse, right? So the video I'm sorry, the I meant the data in the data warehouse needs to be cleansed and transformed, and that's something that's easily consumable by the business users, right? Finally, optimized for data retrieval. right? So the data model should support very quick very quick data retrieval. We will see this in the next slide on how this is exactly done, right? Optimized for data retrieval, but that's one of the important attribute. And finally, the historical data. Transaction system usually does not have historical data, but a data warehouse will always store historical data, right? Sai, did you have any question? Okay, I saw your mouse pointer move over here. That's why. Okay, that's fine. Okay, if no more questions from anyone else, I will move on to the next slide, right? Dimensional modeling, right? So what is a data warehouse and what is a dimensional modeling? Data warehousing, data warehouse or data warehousing is an approach, or it's a high level architecture that says consolidate the data from your different data sources, right? So that's what data warehouse says. Nothing more, nothing less. It says consolidate the data, keep it in a single place so it is easily accessible by the business users. That's what the data warehouse says. Now, how do you go about implementing it? How do you do that is, right? So how you do that is using dimensional modeling. Now, you would have heard of the normalized data model, right? That you built for a transactional system. This is somewhat an opposite of that. In normalized model, we normalize the data to several normal forms: first normal form, second normal form, third normal form. We do that because we want to save space, we want to avoid data redundancy, we also want to avoid update update inconsistencies. We want to keep the data in a very safe state, right? In the ER diagram or in normal modeling. In dimensional modeling, it's the opposite. We don't care about the space, we care about the performance. So here, performance completely takes over space and even data redundancy, meaning some data may be repeated, and even the data model will be denormalized. Denormalized meaning you're storing the same value repeatedly, even if it takes space, right? You store the value repeatedly. That's what denormalized. So dimensional modeling is the chosen uh, data modeling architecture that we use for data warehousing, right? So let's see what are the attributes of dimensional modeling, right? So in dimensional modeling, you have dimensions and facts, right? So as you can see, these are the different dimensions. Now this is something that anybody can easily relate to. Can someone tell me what domain is this? What domain is this dimensional model from? Hello. I'm sorry, I didn't hear that. Okay, it's Sai, right? So Sai has typed in retail. That's correct, Sai. So this is a retail schema, right? And I mean, this one example that everybody can easily relate to. I've probably explained this numerous times before as well, right? So before we look at this diagram, let's just look at the attributes of a dimensional modeling, right? In a dimensional model, what is a dimension? Each perspective, right, or department of performance is called a dimension. So as you see, in a retail industry, if let's say if you're someone who's accountable for the performance of a retail giant, these are some of the dimensions you will have: store dimension, product dimension, customer dimension, date period, and sales order. Store will be like which stores are performing well versus which stores are performing not so well, which product is high selling, which product is low selling, who is my best customer, what is the age bracket of my best or high customers, what is the age bracket of or what is the geography of my customers who account like 20% of my sales, so on, right? Date period, how are my sales this month compared to last month, how are my sales this quarter compared to last quarter, right? And then finally sales order, right? How many orders were there that had more than one product in them, and so on. So these are the dimensions. Dimensions are usually a different perspective from which you want to look at the fact table, right? A different You give it a different context, so that's called a dimension. Probably, I mean, by now I think all of you have a very good understanding of what a dimension is based on your work experience, but this is just like a refresher course, right? Next, the measurable or quantifiable entity is called a fact. So what you see here at the heart is called a fact. This is a star schema, right? It's called a star schema because it sort of resembles a star, right? You have your fact at the middle surrounded by the dimension tables, right? So what is this? This fact is what you measure, right? Fact is what you measure. For a moment, let's go back to the first slide, right? See here, you see all these people. Let's assume this is some sort of a garment factory or some small scale industry, correct? As a supervisor, you are not concerned about what this particular lady is outputting each day, what this particular lady is doing right now, or what these people are working, or uh, how many items have they finished packing today, right? You don't look at those minute details. Rather, you look at how many people in how many products were packed and shipped today by this entire floor, right? When I say how many, right? When you say how many, you are aggregating it. You are doing a sum of the output of all these people here, sum of all the output of all these assembly workers here, right? So that will tell you clearly what is a fact. Any questions? Okay, I'll take that as a no. Okay, good. All right. All right. So that is a fact, something that you measure, right? Something that you measure. Now, fact alone cannot help. Fact should be joined with at least one or more dimensions to give a sense, give sense to that data. Otherwise, just saying, uh, you know, number of orders were this, number of products were sold. That's it. I mean, the measure alone does not have any meaning. It always has to be accompanied by a dimension, right? So that's called dimension and a fact. Now, another attribute of a dimensional modeling is optimized for high select query performance. The reason this is kept in like a star schema, right, is not for it's not for aesthetic purposes. It is not something that looks nice. Actually, this particular design is very well suited for select query performance, meaning this is not in the normal form. This is a denormalized a data model, right? So having these together like this, as you notice, every important dimension table is just one join away from the fact table. I'll repeat that again. Every dimension table is exactly one join away from the fact table, right? Which is what it gives it the resemblance of a star. More importantly, this one join makes your queries much simpler and very quick as well, right? Because it is just a single join. Your query is many times faster compared to the same query if you want to get it from a transactional system, right? So which is why you say a dimensional model is usually optimized for high select query performance. And notice that I am not saying insert or delete here. It is just about select, because insert and delete are again other operations on a database that is more suited in the ETL, in the transactional systems, not in the data warehouse. In a data warehouse, it has to be optimized for the select query performance. Okay. Denormalized. Now denormalized is is something that where you have to store the data more than once and you don't care. You still do that in a data warehouse. Where in the transactional system, you would always want to avoid the data redundancy. You store the data only once, so that when you're updating it in just one place, not in multiple places, right? So that's the attribute of a transactional system. But in a data warehouse, you deliberately introduce redundancy, right? So this point, the denormalized and this point are somewhat, there is a lot of overlap between them, right? In fact, they are the same. All right. So to give you an example, let's say this product dimension, there would be two columns. One would say product category and the other would say product, right? And we are storing both in the same table. As you can say, let's say we go with we go with jackets as the as the product category. Within jacket, the product will be leather jacket, or leather jacket, fabric jacket, and so on, right? And you'll see that the product category value repeats, which is fine. That's perfect for query performance. Had it been a transactional system, it would have been different. You would have stored the category in a separate table. So that's the difference. Here we are not normalizing, we are denormalizing the data. Right. Again, as I said before, a very low updates and delete statement. So we really don't care much about updates and deletes. We do not do it at all. Deletes, we don't do it because we want to retain the history. Updates do happen, but not to a very great extent. Usually any updates come in as a new records. We don't update any existing record because we want to retain the history. So all this together make it very suitable for select query performance, right? Finally, history data tracking, which is something that we have discussed already. We want to store the data. Okay. Uh, okay.
Sandeep, this is Siraj here.
Yeah, tell me,
I
sir.
had one question from the
Yeah.
previous.
Yeah.
So when you are telling that the history data tracking is done,
Mm-hmm.
my first question is: do we store the history data in the say suppose store dimension, right?
Mm-hmm.
So you might be having ample amount of stores opening up every day around the world, and some of them might be closing down or so on and so forth. So would you like to keep the details of the new stores coming up and the old stores closing down in the same store dimension table itself?
Absolutely. So,
I mean, basically, how do you store the historical data is the question.
sure. That, that's a bit of an advanced topic, but I can definitely explain you the theory. What we will do is, like you said, let's say we they launch a new store, right, on a particular date, and then 2 years down the line they are either closing down the store or they are relocating it. What we do in the store
Correct.
dimension table is we will have two date columns, which will be effective date and end date. Effective date will tell us what is the date on which the store became operational. End date will tell us what was the last date on which this store stopped working. So that way you retain the history. Not just retaining history, it's like a snapshot, meaning you can go back to, let's say, a few years before earlier, and you can query like, in January of 2012, show me all the stores that were in operation. Okay. along
Correct.
with the along with the current information. So that is how you store it. And this what do you say, this technique for storing history in dimension tables is called slowly changing dimension. Okay, which we will take up in
Okay.
the next sessions. But slowly changing dimension exactly deals with what are the different approaches that we can take to capture this history.
Okay.
Okay.
Got it.
All right. Okay. All right. So, yeah, this slide is dedicated just for the dimensions. I'm using the same diagram again, but I think by now you have a very good understanding of what a dimension is, right? So they are a logical grouping of attributes. Now one mistake, some people who are new to data warehousing do is they think that a dimension table is driven by a uh, by a table in the source. It's incorrect. It's incorrect. A dimension table should be a logical grouping of same or similar attributes. One example I could give in our quality measurement tool project in BOFA is, uh, we had AIT, application inventory, from where we would get application details such as application ID, short name, full name, and so on, right? We also had RCAT, which would give us the risk information for the same application, and they are same attributes, they are at the same level, and that level is application, right? Just because they are in two different data sources does not mean we will store it in two different tables. They are representing the attributes of the same dimension, which is an application dimension. So such attributes need to be grouped together in the same dimension table. All right. So that's what this first sentence is. You do a logical grouping of attributes which belong to the same entity, right? Second, they cannot usually be aggregated. I mean, there is no point in aggregating. For example, the only aggregate you can pull out of, let's say, the store dimension is how many stores are there, but it probably will not contribute to your metrics or your KPIs or tell anything about how your company is doing, right? It usually has to be accompanied by one fact and maybe other dimensions as well, but it has to be. It alone, as a standalone, it serves no purpose. Any dimension table for that matter, either product alone or just the customer dimension alone, will not give you that much insight, right? And then they serve as different perspective, right? Which yeah, again, it's a repetition of what I've said, like uh, how are my sales from so and so store, how are my which product category is getting sold more, and so on, right? And this last sentence is very, very important, right? Imagine that you are working for a company, right? You're working for a company and they will ask you to do the data model. They will ask you identify the dimensions. In the absence of a business analyst, you are supposed to identify what are the dimensions, what are the facts, and nobody will give you very clear requirements, right? They may, I mean, you would be very fortunate if you do get clear requirements. In the absence of that, how can you identify dimensions, right? What you have to do is ask the business questions, look at their existing reports. Those existing reports will give a lot of insight. They will give you a lot of clue, lot of hint on what the attribute, what the dimensions could be, right? So these dimensions you'll usually find in as sort columns, right? Or in the group by or the filter, right? I mean, this is a real life example, right? In when we started in quality measurement tool, nobody ever wrote down formal requirements. The client never got involved. What we would ask is, we would ask the client to give us some reports from quality center, and the name of the reports itself was very, very helpful. They would have reports like defects by test phase, defects by severity, number of open defects by release, right? That any word that comes after by will be a dimension. Release is a dimension, severity is a dimension, priority is a dimension. So this is like a foolproof method of finding out what is mostly a dimension, right? In the using the existing reports, or when talking to the business will not understand dimensional model. Business will definitely not understand what a dimension and a fact table is. But when talking to them, if you ask them what are your important metrics, they will say something like, oh, I want to see how many products were sold by a particular store, how many products were sold to to a particular customer age group, right? So in those conversations is when you can capture what are the dimensions. Any questions on this? Okay. So then is the facts, right? I think it's all falling together definitely. I mean, I guess you have a very good idea now on what a fact is, right? It's just the remaining part in the star schema. We have gone through the dimensions. Fact is something that is measurable, right? In this retail schema, how many products were sold, what is the profit that you made out of it, and what is the number of products that were sold for in one order, and so on, right? So let's just look at the attributes of a fact. Okay, they are the measurable entity, right? Measurable meaning you can aggregate them however you want to. It could be a sum, it could be a count, it could be a minimum and maximum, and so on. Any mathematical function that can be done. They alone cannot be used to measure performance. How true, right? What if you did not have any of this dimension table? If you just had a fact table, again it would serve no purpose. So they are in together, right? A fact is always expressed in the context of one or more dimensions, right? A fact itself has no meaning. It has to be along with one of these dimensions, right? And then they're mostly aggregated, right? If you don't aggregate it, if you're printing out individual facts, it just means that somebody is looking for an operational report. Let me just quickly go back to the first slide to give you an example. Now if you want a report to say that give me, I want to see a report where there is one row per lady, right? One row per lady here, saying, okay, how many, what are they currently working on? What is their status, or how many items have they finished? That quickly becomes an operational report. You're not looking at the high level number, right? But if you aggregate them, if you, let's say, if you do a sum, show me all the items that have been packed and shipped by these employees on this floor, it becomes aggregated. Now we are looking at a high level number, which you can compare against your target, right? So that is what is fact. So it's usually aggregated. It's perfectly normal for it to be non-aggregated as well, but then it is more used for operational reporting. Right. Okay. I'm sorry, I was in the wrong slide. Yeah. And one other important thing, they also act as a relationship table, linking the various dimension table. Please pay very lot of attention to this. This is very important. I mean, there are chances that you will forget it because it's something that goes unnoticed. I mean, you work with it, you use it, but you never know that it is serving that purpose. So let me explain that. You have all these dimension tables. Like I mentioned, these dimension tables alone on their own serve no purpose, right? You really cannot make any use of it, right? But look at what magic happens here. The moment you have a fact table that is joining these tables together, joining all these dimension tables together, you are in fact creating a relationship between all these dimensions. Now you are suddenly capturing the intersection between all these dimensions. For example, store dimension and customer dimension. These dimensions on their own are not at all useful, but when linked to through the fact table, sales fact table, you have an amazing information, which is which customer goes to which store most often. One customer goes to how many stores, or each store has how many customers coming to them, which store has the highest number of customers, right? So this relationship is only possible through a fact table, which is why a fact table is very important, right? And in a star schema, it is of very high value that that relationship that you get in the fact table is of utmost importance. That gives you a lot of insight, that helps the business uncover a lot of relationship state between these different dimensions. It's very important. I mean, this seems like common sense, but trust me, when let's say when you're attending an interview for a data warehouse, or you're building a data model, people don't realize that fact table is not just a fact table, but it's also a relationship table. It defines how these two how these two dimension or two or more dimensions are linked with each other. It stores that actual relationship, and that relationship has a lots and lots of value, especially for the business. So please understand this, right? Do not forget this point. And before I go to the last point in this fact table, any questions with this? If you want me to explain this again, I can, but please do tell me.
Yes, Sandeep, that would be nice. Siraj here.
Yeah, you want me to explain it again?
Yeah.
Okay, sure. Right. So what I was saying is, if you look at the store dimension, what will be the kind of value stored here? It will be like store 1, store 2, store 3, and so on. If you look at the customer dimension separately, it will be like customer 1, customer 2, customer 3, and so on. These two dimension tables taken separately, for a moment forget that there is a fact table, or ignore all these other dimension tables as well. Just the store dimension and customer dimension, these two tables have no relationship between them. They are completely independent and they are completely useless, right? Just these two tables. But what happens when you introduce a fact table in between, right? Now suddenly this fact table is, on one side it's connecting to the store dimension, on the other side it's connecting to the customer dimension. Now for every fact that is stored, it is also now representing the relationship between store and a customer. For example, now you will be able to say each store, how many customers are there, how many unique customers are there, or you can say for one customer, what is the most visited store, or which is the closest store for that customer. So as you see, there is a relationship that is being built. Or take another example, you have date period and a product dimension. Again, take them separately, they have no value, but when you connect them through the fact table, you can now see that, okay, each product, or let's say product XYZ, how did it sell in the month of January and February, or January in comparison with the month of February, right? So suddenly you have these relationships that are being built or being defined by the fact table. It's completely driven by the fact table, right? So this is what I was referring to. They also act as a relationship table, linking the various dimension tables. Without fact tables, there is no way you can define that relationship. And this is not just between two dimension tables. Now you have 5 dimension tables here. Now all of them are related to each other. It's possible to combine store and product, or store and customer, or store and date period, and so on. This attribute of a fact table is very important. This feature of a fact table to create that relationship, right, is very important. Is that clear, Siraj?
Yeah.
Okay.
Thanks, Sandeep.
Okay. So then the final point being the number of records, right? Of course, the number of records in fact is either equal to or more than the dimension table. This makes sense. A fact is something that occurs more rapidly, so obviously it will have more records than the dimension table. Dimension is something that that changes slowly. Again, in this retail example, you will have 10 stores, but you will have one more than 1,000 sales every day. So your fact table is going to grow rapidly in comparison to a dimension table. So fact table is mostly it will have the same number of rows as the dimension table, or more than it. In most cases it's more. So that's about the fact table. Any questions about facts, what a fact is? See, this whole exercise, I mean, today's session is just about the basics, right? Next session onwards, we'll get into theory, and that is when you will appreciate what you learned today. You'll appreciate, okay, you know, what I learned today and how is it being represented in the tool, right? So, any questions so far? Okay, fine. So with that, we have come to the end of the session. I know I took a lot of time. I said 40 minutes, but we clearly overshot it. So we'll finish it. But before that, I have a small exercise today. Now, what I'm going to do is I will give a scenario to each of you. I'll give you exactly 2 minutes. Now, based on that, you will need to tell me. I mean, anything that comes to your mind, you need to tell me what are some of the dimensions and what are some of the facts for that you know for that case study, right? So I'll start with hotel, right? So Deepti, you pick up this topic hotel, right? After 2 minutes I'll get back to you. You need to tell me what are the different dimensions and what are the facts. Now the key thing here is you have to put yourself in the shoes of a hotel manager, right? If you are running a hotel and if you want to make it profitable, what are the different kind of dimensions and facts that you would have in your data model? This exercise will help you link what the business is asking of you and how you can pass those requirements down to the data model, right? So this is just a small exercise to sort of exercise your brain, right? Right. So Deepti, this hotel is for you, and Sai, you pick up this topic zoo, okay? And Siraj, this is Taylor. I'm sorry, I had not decided on the order. I just blabbered whatever came to my mind. But I mean, there were two more people who were supposed to join, but they did not show up. So your time starts now.
No, so the data is nice.
Okay. Ready, guys? Who wants to go first? Hello, anyone there?
So this is Siraj here.
Yeah, go ahead.
Very quickly, so being a tailor,
Mm-hmm.
I would definitely have a dimension table for the employees who are working for me.
Okay.
Uh, I'll have I'll have a dimension table for the products that I am making.
Mm-hmm.
Not I mean if I say that is a shop where I stitch clothes.
Right.
So what kind of clothes I stitch, right?
Right.
And then I would like to have a dimension table machine. The machines that I am using. So if I'm purchasing a new machine or advanced machine, and if I'm
Right.
not using any machine anymore, and then
Right.
I'll have a dimension called stores,
Mm-hmm.
how many stores I have, and there will be some stores where I manufacture, there will be some stores where I sell my products.
Right.
So yeah, so these four dimensions I can think of straight away.
Sure. And
And I will have a fact table which
mhm,
will connect all these things. So it will be like I can also have a dimension table customers. So
right.
I would know that, say for an example, I would like to know that which I mean, suppose I'm planning to buy a new machine,
Mhm,
right? So I would like to know that which is the machine which is most effective and which is the machine which is not so effective, so that I can take that machine off and get a new machine. So to make that, I would need to know that for a specific machine, what kind of products that machine is making,
right.
which employees are actually working on that machine,
Right.
and the products which are coming out, that is going to which stores, and what are the customers, who are the customers, I mean, what is the customers I'm interact, or is that the product which is coming out from that specific machine
Mhm.
is being sold to the customers or not? If they are, then what is the percentage of sale on a weekly basis, monthly basis, and fourth quarter?
Absolutely. Perfect. Perfect. And I think you thought of it very well. There are a few more things I could add, such as date dimension, right? Time dimension. Like, what is the week, or what is the day of the week when I have more requests coming in, right? And
Right, right,
what is the earliest time that the customers start coming in? What is the last? So that way I can decide how long to keep my employees, right? Let's just assume I have a small shop, right? I can find out, okay, how long should I keep the employees? How long should I have the shutter open, or how early should I open the shop, right, to attract more customers, right? So that would be that. And
right,
um,
right.
then yeah, I think you pretty much covered everything. And few other things I could add is gender, right? Gender of the customers, age group of the customers, right? So yeah, I mean, the
Okay.
the possibilities are endless. The possibilities are endless, but our thinking is important. The thinking here being, how can I measure my business? Based on what comes to your
Yes.
mind, you'll have to build your data model. So, I mean, as a tailor,
Right.
there could be various goals, like I want to get more orders, or I want to spend very little time but make more money, kind of thing. So, based on that goal, your data model will change. But you need to know what you want to measure. That's important. Cool. Perfect. Okay. Then next, who wants to go? Deepti, Sai, anyone?
I Deepti is asking
Oh,
if
disconnected.
she
Okay.
got disconnected. I think.
Sai, you there? You can go ahead.
Yes, Sanjay, can you hear me?
Yeah, yes, yes, I can.
Okay. So my topic is zoo. Basically, so I have I would like to know the dimension of employees who are actually operating staff, and would also mention a different dimension for visitors. Uh, for example, when we have different activities like nature loving club, at the same time, like I have what
Sai,
animals we have.
Sai, your voice is breaking up a lot, Sai. I'm really not able to hear anything. Uh, I know you're trying to say something, but it's very difficult to.
Okay, I'm telling the text.
Okay. Okay. Yeah, I'm looking at what you have typed. Uh, yeah, I think this is great. Again, the I mentioned zoo, but just like a tailor, there would be various performance things in zoo, right? There are various, lot of scope for improvement. So each of these would require a separate data model probably, right? One would be, like you said, how much revenue are you making, right? Another thing that in the zoo could be something like, um, how can, I mean, one of the things that the zoo does is they want to continue the lineage of the animals that are already there, meaning the breeding has to be successful, right? And now think about it. You can have a star schema just for the species, right? You can have a star schema for the species, and you can capture how is the breeding going. Is it good? Is it bad? If the breeding went bad, then why did it go? Because what was the season of breeding, and so on, right? And this could apply for all animals and birds and so on, right? So again, this is a very vast subject, but yeah, I see what you have typed there. That's good. Okay.
Hey, Sandeep.
Yeah, Deep.
What I could think of is we can check for a dimension, maybe a reservation, which will have
Deeptik, we cannot hear you anymore.
type of the room they need. We can have hotel staff and then room status, whether how which kind of room they need. If you think about AC, non-AC, or something. Yeah, sure. I'll do
Yeah,
that.
yeah, absolutely. So, what you just said, it's very similar to a retail industry. In retail industry, you're selling products, but in a hotel, you're selling rooms. So the dimensions that you can think of as customers, age group, gender, whether it's a single occupancy or a multi occupancy. Uh, of course, the type of rooms, if it's basic accommodation or deluxe presidential suite, whatever, right? The season the season is very important. I think they do a lot of analytics on that, because based on that they vary the rates a lot, right? Of course, the staff and the kind of cuisines that they prepare. And again, hotel is like a vast industry. Possibly just one star schema is not possible. You can have multiple star schemas, each focused on one particular performance point, right? So you can definitely have different schemas on it. Yeah, different star schemas on it. Perfect. Perfect. Good. Yeah, I'm happy that all of you answered. That's the answers looking for. So, um, good. Now that you have a very good understanding of what a dimension is and what a fact is, I assure you, any BI tool, all you have to learn is just the small, nitty-gritty stuff, right? Where is the file menu? How do I, start a create report? How do I configure a method report? That's it. If you know what a dimension fact table is, if you can clearly define from the data model, if you can understand what it is, then any BI tool you can easily pick. Okay. So with that, we come to the conclusion of this session for today. Next weekend onwards, we will start with Tableau. Uh, okay, Sai, I see that you have a question. Zoo and Zoo Club and single dimension is a person in between. Okay. Yeah, Sai, this is slightly a complicated question, but my suggestion would be to keep it as a separate table, a separate dimension table, one for the employees and one for staff, because although they are people, here now we are not dealing with people. Here we are dealing with the profits of a zoo, right? So it would be better to keep it in separate tables, right? So sorry, I got distracted. I was just concluding the session. So Now that you have a very good understanding of what is a dimension and what is a fact, it will be very easy for you to pick up any tool. So next week I thought of doing something tomorrow, but I guess it's too early. So we will have our next session for next weekend. Is that okay with everyone? Sai, Deepthi, I think Siraj dropped out. Okay, cool then. All right. So we will do a session same time next Saturday, right? And by then, one homework for you people will be to install Tableau, the latest version from the from internet. Do you know the website of Tableau? Right. Yeah, I will send an email with details. What you do, you go to Tableau and there's something called as a public version. There is a public edition which is a free edition, so please download this, install it on your machines, have it up and running. I mean, it is not as difficult as, let's say, MicroStrategy or anything for configuration. Actually, there is no configuration at all. It is just a client tool. It has no server components. So just download, install it, have it in your machine. Just open it maybe just once to see everything is working. Then sometime midweek I will send you some more instructions if any other data needs to be downloaded. So Saturday onwards, we will start with Tableau. And what I intend to do is I intend to cover the easy chapters first, meaning Tableau is the is currently hot in the market, right? There is a lot of demand. It's easy to learn, right? It's very I mean, if you know what a dimension and fact is, you can very quickly learn Tableau, and it really adds a lot of a lot of weightage to your resume, right? So pick up Tableau first. Next, we will go to one of the BI tools. It could be MicroStrategy or Business Objects or OBI, right? Finally, we will go to the ETL tool and maybe then the data modeling. But first, let's get started with Tableau. Okay, that's the easiest thing that we can do with the most with the most benefit for everyone. Is that okay? All right. Okay, guys. You have a good weekend, and I will send you some some details on the Tableau and all, where you can where you can download and installing it. Just keep a lookout for my email. Okay. All right. You're welcome, guys. See you. Bye bye.